Welcome back, everyone. This is episode 20. We have got so much to go through on this particular video. Episode 20, intro, take 2. Guys, when I started pulling this video together, it was way too long. Episode 20, intro, take 3. Welcome back, YouTube. This is episode 20. As I started pulling this thing together over the course of the last week, I realized it was way too long. First, I thought I was going to divide it into 2 parts. That still didn't work, so now it's divided into 3 parts. The focus of this particular video is part 1, or part A, 20A as I'm calling it, is to run through all of the branch circuit Bonanza activities, all of the branch circuits that I installed, and give you a rundown more specifically on the design and implementation of my source selecting relays. So with that said, let's get started. Welcome back, YouTube. It has been 2 weeks since I have been on this camera, but that doesn't mean I haven't been working. Today's Memorial Day. I wish everyone a great Memorial Day, and we've got a lot to talk about, all of the different things that I've been doing over the past 2 weeks. Haven't had the camera on. A lot of it has been in tight spaces, monotonous, tedious, things like that. Don't know that you'd be very interested, but we're calling this one the branch circuit Bonanza because I realized as I was trying to prep and get ready to start doing my smoke test that I had a lot of unterminated lines all over the place. I had missed a lot of circuits that I needed to run. So I got all of those in place. Got quite a few other things done. Some things not related to electricity. Most of it is. I am really trying hard to get this distribution behind me so I can start working on some stuff that I want to do besides electricity, like actually making this thing pretty and getting finish work done. So with that said, let's start taking a walk and let's run through a few things that I've done, and we'll see what all I got done over the past 2 weeks, and you can tell me what you think about it. So with that said, let's take a walk. All right, well, here we are outside. And here we are staring at the trusty white roof of the bus. One of the things that I want to tell you is last Saturday, the weather was perfect and I was able to get that second coat of white paint on it. So I do have a challenge question for all you that are watching this stuff. There's one thing that I did when I put the second coat on this time that I didn't do when I did the first coat. I want to see if anybody's paying attention. Give me some comments and let me know if you can figure out what it is I did on the second coat that I didn't do on the first one. So with that said, that actually took me all day. I was really disappointed that it took so long, but I had to get up there and clean and pressure wash because of all the pollen and all the other stuff. Got it all dried up, put that second coat on, did a few other things, which is what took so long, and let's see if you can figure out what I did. So with that, we're going to take a walk now, and we're going to go look at the battery compartment, because the battery compartment set the stage for a lot of other things that I had to do. All right, well, here we are at the battery compartment. Let's open this thing up. And would you look at what I got done, y'all. Pull this thing out a little bit. So I put this distribution block in. I had to do that because I needed to be able to get power to my 12 and 24 volt DC to DC chargers from the batteries. One of the things that I couldn't do is I couldn't put those marine rated battery fuses on the top for 2 reasons. Number one, not enough thread height, and number two, not enough clearance. And I didn't want to be arcing and sparking when I opened the battery tray, because those things hit the top of that. So I'll put this thing in. So what you got going on here, this is a 30 amp fuse. This goes to the 24 volt DC side for the DC to DC charger. This is a 60 amp fuse. This goes to the 12 volt DC to DC charger. And this is a 125 amp fuse. And this goes to a DC distribution block that I put inside the bus that I'm going to get to in a few minutes so that you can understand what I got going on there. So anyway, that's one of the other things that I had to do, and I had to get that in place. One of the things that I realized as soon as I connected those cables, my DC to DC chargers came to life because they had power, so that was interesting. And one of the other things that I do want to share, I don't know if you can see it or not, but right here, this cable right here with this PVC coming in through the back side of the battery compartment, that's the 24 volt cable. That's the one that I showed in a previous video. Ran it through PVC, did the splice connectors, and brought it up in here. The other thing that I'll show you is that I've got two feeds coming in. One is for the DC distribution block, and one is for the 12 volt DC to DC charger. And I'll show you some more on that on the inside, make it a little clearer. It's kind of hard to see in here. So with that, let's go back inside the bus. Well, welcome back inside the bus, and look what I got done, y'all. Ain't that pretty? All nice and clean, all nice and squared away. Got everything organized. I'm going to try to keep it that way. Not going to happen, but I'm going to work on it. But anyway, one of the things that I do want to show you, and one of the things that I want to talk about, don't try this at home, but here are two DC distribution blocks that I've added up here. I got a fuse panel down here, and I got a switch panel right here. So this cable right here going into this breaker is the power for the DC distribution block that provides battery power. This one right here is a circuit breaker that goes all the way back to the 12 volt distribution and brings 12 volt distribution up to the front of the bus. This feeds this distribution block. The bus feeds this one. The reason that I did that is for what I am calling, and we'll get into some detail on it, but I'm calling source selection relay wiring. Don't try this at home, guys. All of this is fully documented. It is not to convention for relay wiring, but the electronic components don't care about convention, they care about function, and they work. So the way that this works is that in their normally closed position, which means they do not have power applied to them, all of the circuits that I have on my relay panel down here are getting power from house batteries, 12 volt solar batteries, whatever you want to call them, the house batteries. And they provide power to specific circuits. So I've got one for my dome lights, I've got one for my backup lights, I've got one for my strobe lights, and I've got one for my camera system. My camera system is one of those other things that I got done over the past 2 weeks. Is I got all the cameras in, I got them all adjusted, got them all set up, and I'll show you that in a little bit. One of the things that was really disappointing is I put every one of those cameras in, and I put every single one of them in upside down. That was fun. So I went ahead and fixed that, got them all aligned, got them all set up, which was a pain, me by myself, in and out of the bus, adjusting, moving, sorting, looking at the screen, and making sure that everything was all right. So the way that this works, let me give you a rundown real quick on some of these circuits so that you understand what I've got going on here. So my relay panel here, I got 1, 2, 3, 4, 5, and 6 are not used. And I'm still trying to figure out if I want to use them or what I'm going to use them for. But anyway, so these are not used. The next thing that I'll tell you is, number one is for my dome lights. The reason that I use that is that if the bus is not running, the way that they were wired previously is there were no dome lights. the bus had to be running, key had to be on, whatever the case may be, to get dome lights. So what I did was I set this circuit up so that if the bus is off, I can flip a switch here and I'll have dome lights for I'll have dome lights that will provide power to the domes when the bus is not running. The next one is my backup lights, and my backup lights, I have that set up so that if the bus is not running, all the backup lights that I have at the back of the bus, and I've added some other light bars and stuff like that, if I need to do some work or whatever the case may be back there and the bus is not running, I don't have to put it in reverse. I can actually just turn on a switch and my reverse lights will all come on. The way that this one works, well, let me go back to the dome light. So the original circuit had, when the key powered on, it provided power to the original dome light switch, which which is right here actually. So the original dome light switch, when you turn the key on, it put power to the dome. When you pulled the switch, it provided power back to the dome lights. So what I did was I took that keyed input to this dome switch and put it on the power side of the relay to actually energize the relay. So when the key comes on, this relay energizes. When this relay energizes, I get bus power through this circuit to my dome lights, and they work as they always did through this switch right here. Now going to my backup lights, the way that the backup lights work. So the backup lights, you turn the ignition on and that energizes power to the reverse switch. However, you do not get anything past the reverse switch unless you put the bus in reverse. So what happens there is when I put the bus in reverse, it energizes this relay and it switches over to bus power, and it lights up all my reverse lights. It lights up my reverse alarm, the whole 9 yards, and everything is powered. If I were to take it out of reverse, then it reverts back to running off bus power, and all the lights go off unless the switch is on. Strobe lights is the next one. So I have a bunch of emergency strobe lights, and I'll try to give you a demo of what that looks like, but I have a bunch of emergency strobe lights all over the place. When the bus is running, again, this is on a keyed switch circuit. When the bus is running, all my strobe lights get power from the bus. I put my strobe lights on one of these circuits as well, so that if something happens to the bus and it breaks down and it's not running, or the batteries are dead, or whatever the case may be, and I'm lost, stranded, or broke down somewhere, I can still run all of my strobe lights for marker, identification, notification, safety, all of that stuff, because they'll run off of the house batteries until the house batteries are dead. The next circuit is my security system, which is actually my backup side view and front view cameras. The way that I have this set up is that when I turn the key on, that whole backup system switches to bus power, and while it's on bus power, it's providing me the visibility for what I need going down the road. However, if I'm parked somewhere, when I turn the key off, it reverts over to house power, and if I turn my security switch on, the entire system energizes, and I have security cameras all around the bus that are running off of the house batteries. So that's how this all works. That's how this is all set up. It works. I have tested it. I'll do a demo for you in a bit. I want to run through some other things, and we'll come back to this, and I'll show you how this works. But it works. It is source selecting, so based on the input from the ignition determines where power goes to all of these circuits. One of the other things, so I have 3 horn circuits that are right here. These green fuses right here are 3 horn circuits. These 3 horn circuits, previously I pulled power for the horns off of the fuse block. Well, every time I would blow the horn with the engine running, it would bog down my motor, and I didn't like that. So, and matter of fact, on one of my previous videos where I was talking about the exhaust and stuff, I basically did a horn check in the video, and you could see the smoke puffing up out of the exhaust, and that was because of it bogging down. It interfered with the ECM or something. Does not happen anymore. I've actually tested it, and everything is working as it should now, so that's a major bonus. As you can see, I've got everything marked, labeled, so that I don't lose sight of it. I know what it is because I've been working with it so much, but all of this is a mess right now. I'm going to clean it up. I'm going to get it all sorted out, but I want to make sure that I know exactly where I'm going to put it. Get my dash sorted out and get that in place so that I have a nice dash up here that has all of this stuff in it, so that I have easy access to everything. So anyway, that's that. So again, I want to tell you, this is one of those things where the way that I've wired these relays are against convention. They are not the way that they're supposed to be. The power comes in on the 87A leads of the relay and goes out the 30, and whichever way the relay is, whether it's energized or off, determines what which way the power comes from. That electrical component, don't care. It's just against convention. It works well. They're both electrically and air gap isolated. I don't really see any major issues. I'm sure if there are going to be any, I'll figure it out when the time comes, but at this point I'm not worried about it. I think it's going to work great. One of the other things now, moving on, I wanted to show you is that I do have my backup system installed. This is the screen right here. I've got all 4 cameras in it, and I'll have it on later. But I got front, back, and my 2 side cameras that show up on here. It's really nice. I'm really impressed with this thing. These are my strobe lights. They've been in for a very long time. I just never had any reason to discuss them. I put me a little relay panel thing up here. It translates the alarm lights from 12 and 24 volt systems to the front dash. All of these will light up if anything in the back lights up. Ran the cables, got them all hooked up, got them all wired up. Once again, I'm going to figure out a way to do that nicely and put it into some kind of a panel so it's clearly visible, and I can see those alarms when they pop off. Alright, so with that, I think that covers everything up here. Let's take a walk a little bit further back and let's go through some stuff. Branch circuit Bonanza. Look at that mess down there, guys. So these are all of the circuits that provide DC power to my stove, my hot water heater, and I put a compartment light in here so that when the countertops are on and all of this is closed in, if I need light, I can just basically have a light in here and be able to see everything. One of the other things that I did, if you look right there, I've got my cinders. They're wired in. I don't know if you can see it or not. I'll do something later and get a little bit better detail, but they're wired in there on this side. They're wired in over here on this side. Oh, looks like it fell. I need to get those fixed and get those in. All of the wires run across through the channel. This is getting pretty full. I'm about done. I'm happy for that. And one of the things that I did notice is I'm going to have some issues here. Here's my kick plate location back here. It's kind of hard to see. I'll come back to that in a minute. All the wires run across. Connections up to the hot water heater, connections to the stove in the back of the cabinet. And all of that comes up, comes over here, and boom, look at this. So here is my hot water heater control panel right here. There's my EMS control panel right there. There's my tank monitoring system right there. There's my Servo GX right there. There's my Redodo battery monitor right there, and you've already seen the switches. And all of those things are all working, functioning, and everything else. I got all of that sorted out. All of my relays right here translate to the front. One of the things that I realized in trying to troubleshoot some of the distribution stuff, the way that I have these wired up, this is not all going to work until I get my inverters powered. Wish I hadn't done that, but it is what it is, and I'll get that taken care of. Coming over to this side, you already are aware of this panel, but I've got my battery monitor here. I've got my Servo GX here, and one thing that I want to let you know is I have my 12-volt battery system all in there, all connected, providing power up into this. Notice the pretty blinking blue lights that you can see flashing in there. That's the Servo GX and the Smart Shunt that has power. The Redodo Smart Shunt has power as well. One of the other things that I did over here is I put me a light in the closet to make sure that all of that works. This right here is a USB charger that runs off of 12 volts. I didn't want to have plugs all over the place and plugging in AC things for charging a DC phone, so I got several of these that I'll be locating. I put one back here just to test it, because when I got my Servo GXs in, I had to put some Wi-Fi in here, and my Wi-Fi hotspot was having some problems, and I had to resurrect it from the dead, but I was using that to charge it. I've got my phone connected to it. As soon as I apply power, I'll show you that it'll actually charge my phone. So that's that. I did get all of my relay circuits that I have for the Servo GX for my compartment tent. Here's the probe, and got all of that stuff sorted out. They do work. They actually startled the crap out of me, because I was in here working, and next thing you know, the fans come on, and I was like, holy crap. And it's because the relay was working and the compartment temperature rose. I did have to raise it up a little bit because I don't have any charging sources for the batteries, and I don't want that stuff running all the time right now. But it all works. I'm really pleased with the way that everything's coming out. I know that we said that we would be doing a smoke test live and on the air. We will be doing that. We'll be doing it for the charge controllers. But I did have to get power to my distribution system so that I could get all these circuits in and get them tested and make sure that everything was working. I have not had any issues with anything. Everything comes up, comes on, starts working as soon as I hit the power switch. So, and we're going to do that here in a second. One of the other things that I want to show you is I come back here to the bathroom. I've got a light up there that will be in place over the vanity. I got a light back here that will be in place over the toilet, and I got my switches wired. They're coming in off of a light circuit that will provide power in here. So one of the things that I can tell you is with all of the lights that I have currently wired up in this bus right now, both of my max air fans running on high, and all of my cooling fans on that will come on right now, and my dome lights on, my strobe lights on, my backup lights on. My entire DC distribution system on the 12 volt side only pulls 20 amps with everything on constantly. I don't know if you can see it, but it says right now with I've got a 0.2 amp draw, which is because of my servo and my smart shunt and my DC to DC charger on the Bluetooth side. It says that it'll run for basically 10 days without any charging sources. The same holds true for the 24 volt side as well. But so that's where we're at right now on all of the various branch circuits that we've installed. High water heater, sea level monitor, EMS, Servo GX, Redodo battery monitor, Servo GX on this side. One of the things that I did do is I put a off of the inverter, I put a battery sense input on both sides, on the master on this side over here and on the inverter on this side over here, so that I have another monitoring source for the batteries. If you remember previously, I had put those temperature sensors that I had routed for the batteries. Well, come to find out, they are completely incompatible with the Servo GX, so that didn't work. So having spent $20 on 10 sensors that didn't work, I had to spend $20 on the sensors that I needed that will work, and that was $20 each. So that hurt, but I will have valid temperature monitoring. And matter of fact, I can show you right here. I don't know if you can see it or not, but if I go right there, go to levels, that right there is my monitor for my compartment temp. See, 12 volt compartment. That is the actual monitor that's measuring the temperature inside the battery compartment, or the equipment compartment in the in there. And I've got the alarm set up for that. So that is what I got done there. What else? I'm missing something, guys. I can't think of it right. Oh, here it is. So these lights over here, these are the 24 volt DC lights that I was telling you that I was running on this side. This one represents the kitchen light circuit. It's just one light right now, but I put it in to check it out. I was surprised to find out I bought these because I thought they were 12 volt, but they're 12 and 24, so I hooked them up to the 24 volt side. So I've got one right here, which represents my kitchen lighting circuit. Coming over here, I've got another one over here. This is a 24 volt light as well, and this represents the front area, living room, whatever you want to call it, side of the 24 volt circuit for lighting. My original intent was to have everything all 12 volts and run crossovers. I don't have to do the crossovers anymore. I can do everything on this side 24 volts, and I can do everything on the other side 12 volts, and I don't have to do any crossovers through the ceiling. So that made me happy as well. I was hoping to be able to do some of my AC branch circuits and get those installed. I just did not have time, guys. But that will be part 2 of my smoke check. One of the things that I want to do is take you through the power up of both sides of this thing, get some power on stuff, get everything up and running, go back up to the front and show you how that source select and relay stuff works, and give you a rundown on how everything works with power on, and show you what it's using, what it's consuming, all of those kind of things. So we'll be back in a second getting everything set up and running. All right, YouTube, so at this point I'm breaking the video right here. We're going to call it a wrap on this one. It's not everything that I've got to cover. We're going to go into episode 20B. Episode 20B is going to cover the rest of the items that I wanted to cover in this video. But when I started pulling this together, it was over an hour and a half long, and I didn't want a video that long. So with that, we're going to call this one a wrap, and we're going to move on to the next one.